Hello everyone, my name is Asya Dwivedi. Today I will show you my data science assignment that I have made using Python. So first task was basic of coding in Python. Use of comments in Python. So comments are used to read the line without actually executing it. And comment start with the hashtag symbol with no white space and last till the end. So this hashtag symbol starts the comment and this is an comment. Next, executing commands in Python. So here this is an command, so we can execute this and it get executed. This is an command, we can run this and it get executed, and here is the output. Next, importing packages in Python. So these all are the packages that are import and are also required for this assignment. These all packages are imported. We can import a package with import keyword and then followed by package name. Next, getting data. So here getting data, we have to write these two lines to upload the file as we are using Colab. So executing, we can choose the file from, our desktop, and then we can read that file. Here it is read. We need a .csv file for this assignment. Next is saving output in R. So this is saving output in Python. So this is the output. We can run, execute and save it. Next is accessing records and variables. So to access a record means the column of the table. So here are 5 columns. We can access any of these 5 columns by name of the data set we have used. So here name of data set is dataset dot name of the column. So here we can access the record, and variable are actually the rows. So we need a row index to access it. So here are 1,000 row in this data, but if we need to access fifth, we use this command to access it. So here we run it. So this is the column of price that we have wanted to access, and this is the fifth row that we have accessed. Now, second task was data preparation. So here we have to first add an index field. So we have set first column, that is make. First column, that is make, where name of all the company has been written as the index for this data. So we use this command for making index. We run it, and hence make has been assigned as the index. Next is changing misleading values. So to change, either we can drop the empty rows and columns using this command. And if we want to change any misleading value, like I want to set color, replace the red color with black color, so I can use this command. I can replace red color to black color. And if I want to fill any random value in the place of null value, then I can use this command. So we run this. So here we can see all the columns had been filled except this, because we cannot set any name randomly, so it is empty. So we can use drop command to just drop these rows. Next is re-express categorical field value using Python. So if we want to change any of these value to any another value, so we can use mapping. Like I have to change white as WTE, blue as BLU, and black as BLCK. So I will map this in the colors column. So if we run this, here all the color have come in short forms. Next is to standardize numeric field using Python. So here I need to standardize my price field. So we can use this command, and here we require one of the library, that is standard scaler. Here we have used standard scaler to standardize the price field. So if we run, all the price field has been standardized, and here is now the standardized table. Next, identify outliers. So if I want to identify the outlier in my price column, I use this, and if we run this, here is the final table. So our BMW is our outlier. Next, next task is exploratory data analysis. Here we need to construct a bar graph with overlay. So to construct a bar graph, first we have to create a sample data frame. So this is our sample data frame. Then we have to select column to plot. So we will select it as odometer. Then we will set this figure size. And if we run this, we will get our bar graph. So this is the bar graph. Odometer is the column and BMW. So this is the overlay bar graph. Next, we have to create contiguous table. The contiguous table we can create using two values that we have taken as color and door. So if we see the output, we have three different value for door, 3, 4, 5, and we have three different value for color, black, blue, and white. So here this is the frequency or contiguous table for the door and color. Now next we have to construct histogram with overlay. So here also we have selected column to plot as odometer, and we have convert column to numerical data type using this, and we'll create the histogram. And if we run this, we will get our histogram. This is the histogram, frequency versus odometer. Next, we need to perform binding based on predictive value. So we can create a new bin for odometer's value. So here is the binding based on predictive values. Next task is data preparation phase to model the data. So here first we need to the next task is model evolution. So here need to perform model evolution. So first we will drop all the null value row using this command. Then we will define feature and target variable. So feature will be x and feature variables are odometer and door, and y is target variable and target variable is price. Then we will split the data into training and testing sets. The x train, y train, y test, and this will be the test side to 0.2. That means 80% data will be the trained data and 20% data will be test data. Then we will initialize and train the linear regression model, and then we will make prediction on the test. Then we will evaluate the performance of regression model, and then we will display the mean absolute error, mean squared error, and r squared. So here will with the output. These are the output of the above test. Next we need to do accounting for unequal error cost. So here also first we will perform the test, train and test. We will see prediction, then we will evaluate the performance of classification model with default threshold. Then we will define unequal error cost. Then we will adjust the threshold based on error cost. Then we will see the result we get. So if we run this program, this is the default threshold, this is adjusted threshold, and here is the result, the accuracy, the macro average, and the weighted average. All results. Next task is naive Bayes classification. So here we have to demonstrate application of naive Bayes. So for the above data set we have read, we can perform. First we need to again drop all the null value row. Then we will define target and feature variable. Then we will split the data into training and testing set. Then we will initialize the naive Bayes classifier. Here we have assigned. Then we will train the classifier. Then we will make prediction on the test set. Then we will evaluate the performance of classifier, and then we display the result. So we run this wrong. Here is the result. The accuracy is 0.5 and all this result we have. Okay. Next task is neural network. So here we have to demonstrate application of neural network. So first we will define target and feature variable, split the data into training and testing sets, standardize the features. This is very important. We need to standardize all the features. Then we will build a simple neural network. This is how we will build. Then we will compile the model. Then we will train the model. Then we will evaluate the model on test sets. And then we make the prediction. So if we run, See, these all are the neural network, and these are the prediction result we get. All these are the prediction results. Now next task is clustering. Here we have to demonstrate application of k-mean clustering. Again we will drop the null rows. Then we will select relevant feature for clustering. So it can be odometer. I have taken odometer, door and price as the feature. Now we will standardize these feature. Then we will choose the number of cluster. I have taken 3 cluster. Then we will apply k-mean clustering. So this is the formula. Then we will display the result, and then we will also visualize it. So we will see the graph of the cluster. So this is the result of the cluster. Honda will go in second cluster, BMW in one, then, and this is the result of the cluster. Now next task is regression modeling. So first we have to demonstrate estimation model evaluation use Python. So first we will choose feature and target variable. Then we will split the training and testing set. Then we will initialize and train the linear regression model. Then we make prediction or test set. Then we evaluate on various metrics. So here we will this these are the result of a model evolution. Now next task is dimension reduction. So here we have to demonstrate how will we identify multicollinearity. So first we will define feature, then we will add a constant term for intercept, then we'll calculate VIF for each variable, and this will identify multicollinearity. So this is the result. Now next task is demonstrate how will you apply principal component analysis. So first we will define features, then we will standardize that feature, then we apply PCA, then we create data frame to visualize the result, then we display the principal component data frame, then percentage of variance explained by each principal component, then cumulative variance explained. So this is the result of the above task. Now for the remaining task, I will require another data set.